𝐂𝐨𝐧𝐿, Associate Director Marketing here at Lambda Test, and would be your host for this session. Today, we are diving into an exciting topic that pushes the boundaries of browser automation. Yes, that is reactive browser testing with WebDriver BiDi. And for this session, I'm delighted to introduce 𝐒𝐫𝐢, software engineer at Google, and 𝐒𝐫𝐢, engineering manager, open source program office at Lambda Test. With nearly a decade of experience in test automation and development, 𝐒𝐫𝐢 is a committer for projects like Selenium and WebDriver IO, and a member of technical leadership committee at Selenium HQ. 𝐒𝐫𝐢, starting his career in 2004 as a web developer, now focuses on browser automation at Google, with his current efforts centered around the WebDriver BiDi protocol. Together, they will deep dive into the world of WebDriver BiDi, especially BiDi architecture and capabilities. We will explore how to set up BiDi sessions, capture browser events like network requests, console logs, and JavaScript errors, and build a robust reactive automation flows that reduce flakiness and accelerate feedback loops. The session includes hands-on demos, guidance on adopting BiDi and migrating existing tests, and curated resource of continued learning and implementation. Feel free to drop your questions in the chat and we will address them during the Q&A session at the end. And do share about your favorite moment for this session on the social media with the hashtag TestMu and stand a chance to win exciting prizes. So please join me in welcoming 𝐒𝐫𝐢 and 𝐒𝐫𝐢. 𝐒𝐫𝐢 and 𝐒𝐫𝐢, it's over to you.
Hi everyone. This is the section we are going to make today. So,
hello everyone. This is 𝐒𝐫𝐢. I'm working as engineering manager at Lambda Test for Open Source Program Office. So I'm an open source enthusiast and I love to contribute to the open source projects. So in my experience, I have contributed to Selenium, APM, and WebDriver projects, and I'm the current TLC of Selenium. Over to you, Max.
Yeah. Hi everyone. Thanks for joining our presentation. My name is 𝐒𝐫𝐢. I'm working for Google, focus on browser automation, specifically on WebDriver BiDi protocol, its specification, and its Chromium implementation. So that is what our workshop will look like. I will make a presentation about what WebDriver BiDi is and its capabilities. Then 𝐒𝐫𝐢 will show you the specific scenarios where you can use it and how you can use it right now. So if you want to apply the practical part of the workshop, please scan this QR code and clone the GitHub repo locally. You can also check it out later after the presentation, whatever way you prefer. So these are prerequisites for the workshop. You will need JDK and Maven, also Google Chrome, Git, and this repository. Do you want to add anything, 𝐒𝐫𝐢?
Yeah, so I have created a WebDriver BiDi starter pack that contains few code samples that you can try out for the WebDriver BiDi. So you can try to clone that repo and make it ready. And if possible, you can install and set up everything, JDK and Maven, so that in the workshop, we can have the live demo and you can actually try and execute those test cases.
So in my part of the presentation, I'm going to talk about WebDriver BiDi protocol itself, what it is, why we are working on it, how it works, and give you some examples of what it's already capable of. So I hope everyone who wanted did scan the QR code with the repo. So let's jump into the theoretical part. So we are all developers and QAs, so we know the deal. We have to make sure that our applications work everywhere. And for years, the main tool for this have been WebDriver Classic protocol. It's a set of rules that lets our script drive a browser. WebDriver has been around for a while. It started with Selenium, and in 2018, it became the official standard for talking to browsers. Its main goal was to give us one API that worked for every browser, so we weren't stuck with just one. We could use one test for all the browsers. The classic WebDriver protocol worked on HTTP transport with a simple command response model. Your script sends a command like click this button. The browser executes it and then sends back a response like, okay, I clicked it. This was a very reliable system. However, it didn't allow for running several commands in parallel, and it didn't allow for events neither. In parallel, we had the Chrome DevTools protocol, or CDP. It was a very powerful tool based on bidirectional WebSockets, allowing for events and parallel comments, whatever not. Also, it provides deep insight into the browser's internals. Both its privilege and its curse is the fact it's a Chrome-specific protocol that only worked on Chromium-based browsers like Chrome, Edge, and others. It's a privilege as it allows for fast development. However, it didn't allow for other browsers vendors to implement it. So CDP testing tools were stuck with Chromium browsers. So we had a problem. WebDriver Classic was a standard and worked everywhere, but it didn't offer deep control or insights. On the other hand, the Chrome DevTools protocol was really powerful and let us see inside the browser, but it only worked with Chromium browsers, and we needed a way to get the best features of the both protocols. So the solution is WebDriver BiDi. The idea is to create a new standard protocol for browser automation, which will be based on bidirectional transport instead of HTTP. It takes the lessons learned from the power of all the protocols and builds them into a proper cross-browser standard. It gives us a single modern way to automate all the browsers. Importantly, this is the official next generation standard. All the major browsers vendors, Google, Mozilla, Apple, Microsoft, you name it, are developing it together as a W3C standard. This is a new way forward browser automation. In Chromium browser, the CDP is still in place, but we have a special mechanism and translated WebDriver BiDi protocol to CDP. We call it BiDi CDP mapper. The WebDriver Classic is still supported by the Chrome driver binary itself, but for the WebDriver BiDi, we have an extra layer called BiDi CDP mapper. It encapsulates all the BiDi to CDP translation logic and transfers it like shown in the picture. So WebDriver BiDi uses a bidirectional WebSocket connection. It's not just about performance. The classic HTTP protocol only allows for a request response model where the client has to ask for everything. A WebSocket creates a two-way channel. This means the browser can send events to the client at any time, which is not possible with the old protocol. Another new possibility is sending several commands without waiting for the previous to finish. So in this example, you see we send command 1, command 2, then the second command finished, then we have some events, and only after that, the command 1 finished. So the communication uses simple JSON messages. There are two types of them. It's commands, which are sent from our test script to the browser, like you create a new tab, navigate, or perform some actions. And events, they are sent from browser back to our script to notify us that something happened, like new browser context created or some JSON, console message arrived. So I'm showing you these real BiDi protocol messages so that you'll not be surprised next time you open verbose from driver logs. That's what you will see. So here are some examples of the commands and events. As I mentioned, it's navigation, creating new browsing context, etc. So let's talk about subscribing and events. The main idea is subscribing to events. We tell the browser what we are interested in. For example, we can subscribe to all console errors. Then as soon as an error occurs, the browser instantly emits the log entry edit event. We can assert there are no JavaScript errors on the page or something. So WebDriver BiDi is split into models, and I'm going to briefly walk you through them. So browser model, it's responsible for window states and creating user contexts, which is analogous to incognito modes. Browser context mode model allows you working with the specific tabs. You create, navigate, make a screenshot, make PDF, you name it. Also, it allows for locating nodes, which is quite a useful feature as well. The emulation mode is a very powerful tool within WebDriver BiDi. It allows testers to simulate various conditions and environments. For example, you can emulate geolocation. You can emulate dark or bright theme. You can emulate locates, screen orientations, time zones, whatnot. Input is intended for all kinds of input emulations, including touch gestures. Log model provides log entry edit events. Network is another powerful model. It allows for network request interceptions and a bunch of other things. Script is responsible for running scripts, and it also provides mechanism for preload scripts. We'll cover that example a bit later. Session provides subscription mechanisms. Storage controls cookies. You can get, set, remove cookies, and use it. Web extensions allow to install and uninstall web extensions. So one of the features of WebDriver BiDi is that it's extendable by design. So here are some examples of external specifications. So permissions allow you to set web permissions, for example, to access geolocation. We'll get to that a bit later as well, or to emulate web Bluetooth devices, which can be really useful as well. So here are some of the testing tools already adopted WebDriver BiDi. Cypress, PPT, Selenium, WebDriver IO, already using that. So this new model gives our tests many new capabilities. We'll now look at some of them. We can listen to logs, intercept network traffic, emulate different environments like geolocation, etc., and make preload scripts. So let's dive into one example, listening to console events. So I'm going to give you a scenario. So let's start with this. It allows you to listen to any messages that appear in developer console. That includes logs, warnings, and most importantly, any uncoded JavaScript exceptions and their stack traces. First, you have to subscribe to the event, and then write something to the console log. And as a result, the log entry edit event will be emitted. So let's check a real example. Let's say we want to test this web page. I want to test that clicking on espresso cup updates the total sum. Voila. Verify the total sum is updated. All good. Or not. Let's check the pages console. Uh-oh. Some additional workflow is broken. In this example, it was added intentionally for presentation, but it can be some additional functionality like collecting users' discount card from cookies or saving their preferred drink, whatever. So this can be dangerous, and now we can detect that kind of regressions. Another very powerful model is network. It lets you to intercept and inspect any network request. You can intercept all or some network requests. Also, you can set up data collators to access the response data afterwards. The before request sent event provides you request data like URL, headers, cookies, and some else data. This method allows you continue intercepted request with custom data like body, header, and event method or URL. Or you can even provide the custom response, including body, by using the provide response method. Meaning you can mimic a specific behavior of the server when your page accesses it. The response started event provides you access to the response URL, status, headers, and then you can continue response with some custom cookies, headers, status, code, so whatever. And you can also access the response information once the response is complete. Also, you can access the response body by calling the dedicated command for that. If you set the data collector before, you can access the data collected by the collectors afterwards. So this provides you a very powerful mechanism to control network communications and allows for several very useful scenarios. So let's take a look at this example. Let's say we want to improve this cat lovers Facebook page. So with some interception magic, we can make it more dog friendly. So yeah, why not to use BiDi for that? Another example is for testing how your application handles server errors. Basically, you can mock server API. With WebDriver BiDi, you can intercept the network request and override the response with anything. So, for example, 500 HTTP status code. And this lets you test error handling logic without needing a complex server setup, etc. You can also use network events for security checks. Your test can inspect the request and response to have the correct security or other required headers. And another model is a script one, which allows, among other things, it allows you to add preload scripts. So there are JavaScript snippets that are guaranteed to be executed on a page before any of the page's own code runs. So you can, for example, override web APIs, add DOM listeners, whatever. Or like in this example, you can override the math random method so that it returns always the predicted value. It allows you to make your test reproducible and making the scenarios consistent. So if we run that method and then call mathRandom, it will return the specific value. Another example of what is possible is geolocation emulation. So if your website relies on geolocation for any reason, it used to be painful to test it properly. So now with WebDriver BiDi, you can do it easily. First, you need to provide permissions to access the geolocation, and then emulate any desired geolocation. So in this example, if I navigate to our website, for example, Google Maps, voila, you are transferred there. My colleague 𝐒𝐫𝐢 will cover this example in more details a bit later during the workshop. It's a very powerful scenario. I like it. So there are a bunch of other emulations available. You can emulate a specific locale, a specific time zone, or even emulate the situation when the user turned off JavaScript on their browser. So with that, I am handing over the microphone to 𝐒𝐫𝐢, who will show you some specific examples of what we talked about.
Yeah. Thank you, Maxim, for the wonderful theoretical session. So let me share my screen. I'll go with the slides. Sorry for that. Yeah, so we are switching now from the theoretical part to the practical part, and I just want to recap a few things before we jump into the practical session. So small recap is that what is WebDriver BiDi? So WebDriver BiDi in simple terms is a WebSocket connection that is enabled via capability, and it streams over WebSocket. That means as it's a WebSocket connection, you can subscribe to events and you can listen to the responses instead of polling, right? So the goal for the next hour is what we'll do is we will actually enable WebDriver BiDi with our Selenium test cases and subscribe to few events, listen to console logs, and see the network request and responses. And we also emulate the geolocation as Maxine said. And coming to the workshop pattern, the workshop signals for the persons who are going to try to execute the code samples. So the signals for today is the audience who are going to actually execute the code during the live. You can just paste these signals in the chat so that we can get back to you if there are any issues in running the code, or if it is working, or if you are stuck, or if it is hanging, or you can post them in the chat anytime. So the format loop is, I have a couple of examples that I'm going to do in the workshop. So first, I'll be explaining what I'm going to do. And second, I'll be doing the demo. And I'll let you try for 2 to 3 minutes. Meanwhile, for the persons who are not trying that examples live, we can recap in 1 minute and what we have done so far. Okay. So let's directly jump into the session. So first, what we are going to do is we are going to enable BiDi in Chrome, and we will verify that the BiDi bridge is available to Selenium. So we are going to use Selenium to enable BiDi and interact with it. So enabling BiDi opens a WebSocket connection in the behind, and it can send commands and it returns events to us, right? Yeah. So let me share my screen before before jumping into the coding session. So this is the WebDriver BiDi starter pack that is available in my GitHub, asha509/WebDriver BiDi starter pack. You can try to clone, and if you have Maven and Java ready already, you can directly open the project in your IDE and we can get it started. So the plan is I have already cloned the starter pack in my local. So let me know if you are able to see my screen. Anyone? Voice up. Great. So this is my WebDriver BiDi starter pack that I have cloned. The idea is more simple. I'm going to present few examples with enabling BiDi, listen console events, and listening to the network request and responses. And we will also do a reactive form validation, and we will also emulate the geolocation. So for each Java file in here, I have marked it to do. Okay, this to do is something that I'm going to explain, and you can also try it out meanwhile parallelly. Okay, so while I write the code, if you feel that if you are not able to follow me, or it's not able to, if you are not able to see it, for every Java file, I have a respective MD file that has the code that you need to replace in that to do. So this is the scaffolding template project, so that what I've done is to make it easier for you all. You just need to copy the code and place it in the to-do, and you can start running the test. Okay, so the execution and the commands to run the test is also available in here. Okay, right. So first we'll start with enabling the BiDi session in Java. So for that, in this project, I'm using Selenium 4.35, which is the latest release, because we have geolocation implemented in the latest Selenium version. So that I'm using 4.35, and I'm using Java 17. It's my personal choice. You can use Java 11 plus any other version to make it work. That's it. So I'm using only two dependencies and the latest Chrome driver and the Chrome browser. So there is no need to install the Chrome driver. It is done automatically by the Selenium. Coming to the code sample. So there are few terms I want to explain before jumping into the workshop, before executing or modifying this code sample. So the terms are, first one is the WebSocket URL. So the WebSocket URL is nothing but, I'll write in here. WebSocket URL is nothing but a URL that is returned when we start a session, and with capability WebSocket URL to true. So this is how we are going to start a BiDi session. This is what it makes the difference between a classic WebDriver and a BiDi WebDriver. So one capability can change a lot in here. So that capability is the WebSocket URL. Okay. And second thing is the local end and the remote end. So when I say local end refers to my Java client from my machine, and the remote end, when I refer to remote end, it says like, the browser will be the remote end in here. And the other term I'm going to use is browsing context. Okay, so browsing context, in the BiDi, it is a module, but in simpler terms, it is a page frame that we work on actually. So when you start a session, you will see a page open, right? So that page will have some ID. We call it as the context ID. We use that context ID to operate commands on the browser window. Okay, so it is more simpler that in Classic, when I compare to Classic, it is more simpler to get window handle. Okay, so when you do get window handle, you can get the ID of that window handle, right? So that is the context ID we are going to use it in here. And the fourth one is the readiness state. So readiness state has three states, which is none, complete, and interactive. It is also mostly similar to the page load strategy in Selenium, right? So we have none, eager, and normal. So it is the same in BiDi. So we have none, complete, and interactive. So it is the if you want to compare, it's the same page load strategy in the classic WebDriver. Okay, so we are using all these terms in this example. That's why I'm going to I have explained these terms. So what I'll do now is I have the code in here. Coming to the imports, I have imported few Selenium imports, which checks the BiDi, which are the BiDi packages, and to set the capabilities to operate to instantiate Chrome driver, and to set the Chrome options and everything. So these are the BiDi packages that I have imported. Browsing context, that we are going to operate on the context ID to set the URL, to capture the screenshot and everything. As Maxim said, you can do a lot with the browsing context ID. This package has all the references and the methods to it. And the browsing context will have the navigation result too, and it has the readiness state too. So we are going to use that in our code sample. So this is the scaffolding template that I have already have to make it easier for you. What I've done is I've created a class called enable BiDi, and I'm creating the Chrome options object in here. And these are not mandatory; these are optional. If anyone wants to use it, if anyone is using oldest Chrome versions, the BiDi mapper, you will see a new different window, the mapper window. But if you're using a Chrome new versions, you might not see the mapper window. This might not work for you. Okay, so I'm setting the Chrome options in here. So before setting the Chrome options, now we'll have the first to do. What we are going to do is we are going to start the BiDi session by setting a capability. Okay, so we have the capability options dot set capability. What you need to pass is, first one is the WebSocket URL. Okay, and it is a Boolean flag in the capability, so you can set to true. By default it will be false. So when it is false, assume that you are starting a classic session, and when it is true, you are starting a BiDi session. So what happens is, when you set it true, the session will actually return a WebSocket URL in the behind, and Selenium uses a WebSocket URL to send the commands and listen to the events and subscribe to the events. Okay, so this is the command to enable the BiDi. And now we have enabled BiDi and started the session. Now how we are going to operate, or how we are going to send the commands to the browser is with the browsing context. Okay, in order to create a browsing context, we have a browsing context class in here. So you can see so what I'm trying to do is, I have already a variable called context in here, the browsing context class object. So in that context, what I'm trying to do is, I'm trying to fetch the context ID first. Okay, so I'm passing the driver instance in here, and I'm saying that start the browsing context with the current window handle. Okay, now it fetches the context ID in here. So if you want to print or see the context ID, you can say and context.getID. If someone wants to see what context ID is, you can print the context ID. So this is how now we are actually linking our BiDi session to that browsing context. Okay, now with that context, what we are going to do is we are actually trying to send this URL. This URL is nothing but a plain HTML code that says WebDriver BiDi is on for me. So I'm now going to send that URL in that context. Okay, so you have to edit the third to do in here if someone is trying live. So I'll have a small variable. So if someone is actually trying the code samples, sorry. If someone is trying to try the code samples in live, you can directly copy from here. I'll do the same because it's taking a lot of time to type in here. Okay, so what I did in here is with the browsing context package, I have set this URL. I'm saying that navigate to this URL. We have a method called navigate for that context, and wait until the readiness state is complete. So we have three states, as I said: none, complete, and interactive. When you say none, it won't wait for anything to load, even with the images or links. It directly starts going to the next operations. So if you are saying interactive and complete actually it waits until all links are loaded. Okay, so if you want to print anything, you can just print the navigation result. Maybe I'll just copy all this logger info in here too. Okay, so in here I have put a sleep in order to showcase how the page is looking and how the BiDi session is getting started. And we also see the capabilities. We will see the capabilities, what actually the capabilities got printed in the console. So everything is in place to execute the first code sample. You just need to go here, copy the command, and execute. So the session is started. This is the BiDi session, and it says the WebDriver BiDi is on. So the context is actually loading the URL in this browsing context, and it's working perfectly. Okay, so it waits for the 30 seconds for the people who are executing. Now, if you see the logs in here, as we have started the BiDi session with WebSocket URL true, you will see a new WebSocket URL that is when you print the capabilities, you should be able to see the WebSocket URL. So this is the WebSocket URL that we are using in the behind for the Selenium session, and we are actually sending, receiving, or subscribing to events, and we are listening to events. Okay, so what happens if I set now WebSocket URL to false? It should fail because we are starting a classic session in here. So you will see an error. If you set to false, it says WebDriver BiDi is not enabled because in Selenium we have an interface called has BiDi in here. So what has BiDi does is it exposes a method called get BiDi. So if you enable WebSocket URL to true or enable the BiDi, this method will be available to you. If you don't enable, then this won't be available to you. So if you have any script that you want to switch to BiDi and classic, or if you want to execute based on the conditions, you can use these interfaces to design your script accordingly. Okay, so coming to now, what happens when we also do the driver.quit behind? Okay, so in Selenium, when we do the driver.quit, always remember that we are actually cleaning up the sessions. If you compare the classic, like we are cleaning up the sessions and closing the browser, deleting all the things, right? So in BiDi session, when you do the driver.quit, we are actually removing all the listeners or removing all the subscriptions that we have subscribed before, and we are closing the BiDi session, that's the WebSocket URL, we are disconnecting it. So this is what the cleanup happens when you do the dev.quit in the BiDi session. So it is a bit different when you go with the BiDi and Classic. So in BiDi, we should be like unsubscribing to the events and removing all the listeners that we have registered. Okay, and coming to the capability, this was the capability that we have introduced before, WebSocket URL to true. So, and also for the convenience thing, like, we don't want to users to set this URL manually or do it. So we have more convenience method designed in Selenium. You can also use options.enable BiDi. So this does the same work for you. What it does behind, it sets the WebSocket URL to true. So in order to understand, like, in order to explain you what actually turns on the BiDi session, I have provided this example. So as we run the example in the classic with WebSocket evolved to true, false in set capability. So this is the classic session. You can see there is no WebSocket URL in the capabilities. Okay, so this will be acting as a classic session. Okay, so this is what it makes a big difference with one capability. Placing WebSocket evolved to true starts the BiDi session, making it false, or by leaving it by default, it starts a classic session. Okay, so any questions on this example part? Anyone? Let me see if I have any questions in the chat. Great. So if everyone is okay, I'll go with the second example. So as we have started the BiDi session as with the using the WebSocket URL to true, what we are going to do is now we will actually try to listen to the console logs. That means we are actually going to subscribe to the log events, and we are going to use the log inspector class in Selenium. So what that actually does is when there are any information or error logs or like debug logs in the console, you can actually capture in the real time and you can use it for the debugging. Okay, so always remember, as BiDi is bidirectional, the browser can push events back to us over WebSocket, such as console entries in our case. Okay, so, I'll go with the second example now. Closing the first one, I'll open this console event subscription. Let me know if I'm going too fast. So I have created the Java file. This is also a scaffolding template with the console event subscription class. So what I'm trying to do is, first I'll try to explain what this URL contains. Okay, so this is the sample URL that that is also available in the Selenium documentation. I'll switch to console in here. So we have 4 buttons in here for click me for console logs, click me for console error, click me for JS exception logs, and click me to get the error stack trace. So when I click it, you can see there is a live the logs are emitted into the console in here. Okay, so this is how this page works. So what we are trying to do is we are trying to automate this page, and when we click on the console error, say console error, and it prints this console error, and I want to capture this with my script and use it for the debugging. So for the demo purpose, I'll be only using one example, like I'll be only clicking on the console error and looking for the logs and capturing the logs. So you can also try it out with other buttons and capturing other logs. Okay, so now going back to the code sample, is the same thing, but for this to make it more easier, I have already set the WebSocket evolved to true. Instead, we can do one more thing. I can do enable BiDi by default, so this looks more easier way. Okay, now when I said enable BiDi, now the WebSocket connection is on, and now as I said, when we are starting the session, it launches the browser, but we need to operate in that browser, or we need to connect that browser to the our BiDi session and operate on it or send commands. We need the browsing context ID again. Okay, so you can get the browsing context ID by using driver.get window handle. If you have multiple tabs, it's more simpler. Get window handles, and you have to switch to, like, the respective window you want. You have to choose it from the array. It is more simple. And now for the logger info, what we are going to do is we are actually going to use the log inspector class. So coming to the terms in here again, so we have a term called event subscription. So we tell BiDi which events to stream that we care about. Here it is a console entries. In our case, we are using log entry.add. Okay, so when the logs are emitted in the console, the log entry added actually streams that log from the browser, and it pushes to via WebSocket, right? So, and the term we are going to use is console log entry. And console log entry is nothing but it is a structured record with fields like it is like a response, which will have method, text, and what type of log it is. Like, it is a info, warn, error, debug log, or JS exception. And text contains the message, and method is the console method. And we have log inspector. Again, I said it's a Selenium helper that writes the BiDi log module and invokes the callback for each console entry. Okay, so now to do that, we have a package called log.consoleEntry in the BiDi module for Selenium. So I'm going to use this console entry package. And now let me go and see. If someone is trying out, I'll just go with you. So as we have already enabled the BiDi session in the console script, now what we are going to do is first we are going to use the log inspector class and instantiate a log inspector object. Okay, so you can just copy this and place this in here. So we are passing the log inspector, creating the object in here, and we are passing the driver. And now that we have this log inspector, it enables a lot of things for us to listen to the logs now. And you can use the log inspector.on console entry to capture the log. But before that, there is a trick in here. So when you are automating or when you are interacting with the browser via WebSocket connection, so the browser is actually sending the response or streaming the events to you. So in here, in console logs case, we are using the completable feature. It's a Java package again. So in order to bridge the asynchronous BiDi event callbacks from the console log inspector, we are using the completable feature. And because the WebSocket connection fights on a main thread, uh, when it returns the response in an event callback, it is going to fire on a different thread. And when the browser actually pushes in an event, right? So we are using the compatible feature because to handle the asynchronous event, I can say in simple words, because you cannot expect like when the logs are going to arrive, right? So we are going to use the completable feature, so that, and we are also going to wait for 5 seconds to make sure that the logs are actually printed in the console, and we are ready to capture. Okay, so I'm using the on console entry, the same log inspector dot on console entry. So here we are going to fire a callback, register a callback called event. So if anyone wants to copy the code sample, you can directly copy the code sample. I'll do the same in order to save time. Right. Okay. So I have registered a callback call on console entry in here. Now this console entry, what happens is when there are any events triggered in the console, it actually captures it. Okay, but also I have additional things in here, the console feature, and because I want to only capture once in here, the first console entry, and I don't want to capture all the console entries because I have only one. But if you want to capture all the console entries, we have another example, reactive form validation, which is more interesting. Okay, and now we are going to register it. So if you see that code sample, actually, if you look carefully, we are actually subscribing to event, like, on console entry event in here before we actually hit the URL, right? This is because we are actually trying to capture every log or the logs before the start of the session. uh, I don't want to miss any logs when the browser launches and when it is automating things. I don't want to miss any logs, so I'm just registering or subscribing to event before itself. If you subscribe to events in the middle of the automation, what happens? It will only start subscribing to events that happens after, right? So it is the best idea, like it's the best way that we actually subscribe to events before starting the actual navigation and automation. Okay, so this is what I'm doing. I'm registering on console entry, and if you see in here another to do, what I'm trying to do is I'm trying to wait for 5 seconds and print all the console events that I got after clicking on the error button. So what I'm trying to do is I'm trying to open this URL in the context window in the context, and I'm trying to click on the console error. So when I click on the console error, I'll get an error in here in the console, and we are actually trying to capture it after the error is registered. But before that, we are actually subscribing to events. It starts listening, but when I'm printing, after clicking on the button, I just want to see logs what happened. Okay, so you can replace another to do with the same. Okay, so here I'm actually waiting for 5 seconds because I cannot expect sometimes if I immediately click on the button that the console will arrive, right? So I'm just giving some timeout. So in your case, this is not my case because I'm actually the error is immediate. But in your case, if you feel like, okay, when you click on something or when you do some operation, if the console logs are a bit delayed, then you can set the timeout to wait for them to arrive to emit in the console, and you can start capturing it. Okay, so on console entry that we have subscribed in here, right? Now you can also get the type method and get text of the console thing. Not only the error, we have said console events will have three things like method, text, and type. Okay, so you can see what the console type and what's the method and what's the actual text. That means if that is an info or error, it will be printing the actual text in here. Okay, so now we'll be going to execute this code sample. The same process. When you go with the MD file, you will see a command in the top, and you can just copy that. Make sure everything is right. You have replaced all the to-dos, and I'm going to execute. Okay, so the window, what happened is it launched the URL and clicked on console, and it immediately closed. But if you see the logs in here, now what happened is we have triggered a console.error. We have clicked on it, and it has printed I'm a console error in the console. Okay, so if you click on that, if you can see more stack trace. But if you see the method type is console, the method is type error, and the text is I'm console error. So it might be different if you're trying to click any other button, like different button. It might be a different it's an info JS exception, and the error might be different. Okay, so this is how you actually capture the console events, or when you actually subscribe to console events and listen to them, and it will help you for the debugging purpose. Okay, so I'll give a 1 minute if someone wants to try, and I'll look into the Q&A things if someone has any tried and pasted any. Just give me a minute. Okay, I don't have any people trying out, I assume. Okay, any questions so far? You can ping in the chat or Q&A session. Great. So the common pitfalls for the console things is like you should not subscribe too late. Like I said, you have to subscribe before you want starting the session, because subscribing too late can actually miss the logs after you navigate or things. So if the even in the future times out confirm the button if you have the console events that arrives late in that is emitted late in the console, uh, then you have to make sure that you are using or you are waiting for the console for respective amount of time. You can use the completable feature for that. So in simple words, computable feature is actually going to wait until the async BiDi calls are um, done. So I'm not sure. Yeah. So in here, if you see, we have subscribed to the log inspector event uh, on console entry mainly, and we are listening to logs. But I don't want to keep that open. I want to close the subscription that I have made. So I'm using the log inspector.close in order to unsubscribe for the log inspector, or to unsubscribe from the logger events. So you can use this one. I'm checking that if log inspector is not null, that means which I'm subscribed already. I want to close the log inspector. So for every event, the structure follows like this. So there will be a BiDi module, and BiDi module will have a command, and that command actually subscribe to the events, right? So every BiDi module has some of the events. So when you are subscribing to that, make sure that you also unsubscribe or you close it to make it more cleaner. And again, you can ask me why to close. Dev.quit is already doing that. Yes, it is doing that. It's a safe check. I do. Okay. So now, if you are good with the console event subscription, now I'll go with the reactive network events. Okay. So network events is more interesting in here, because in network events, I'm actually using the network module, and I'm navigating to a site, and I'm actually capturing all the requests and responses that I get when I navigate to that site. Okay. For example, what I do is I'll go to the selenium.app. Okay. So, sorry, I want to inspect it. And in the network, so assume when I refresh, you see a lot of network requests, and what happened. There are some requests sent, and there is some response heard, and you want to see, or you want to fetch all those network logs, and you can also intercept the network, as Maxim said. But for this example, I'm just going to listen to the events, and see the requests and the responses. Okay. Again, the same approach. I'm going to use the scaffolding template, and we have respective MD file to replace the code. And the module I'm going to use is more simple, Selenium BiDi module.network. In order to capture response details and request data, I have the supported methods in the BiDi network in here. I'm not going to start any I'm not going to write any code to start the BiDi connection. It is already turned on in here, and I'm just going to have a small check with has BiDi instance to make sure my BiDi connection is already on. Okay. Now, before going to hit the URL, what I'm going to do is I'm going to subscribe to the events on request sent, on response received, on errors for the network events. Okay. So as Maxim showed in his file, we have on before request sent, on response completed, and on fetch error are the three events that you can subscribe and listen to. Okay. So now we are going to do the same. First, we'll go with the before events. So you can first instantiate the network object in here to interact with the BiDi. Okay. Now you can ask, there is no browsing context because I'm not doing much things in here. I'm just using the Selenium classic driver.get because I want to actually show how backward compatible we are. You can use both if you are using BiDi and classic. I just want to see on before request send what happening. Okay, once we'll try this out, and once this works, and if you see the live logs in the console, then we also see the response logs. Okay, so what I'm going to do is I'm just going to copy the command to execute this code, and see. So I'm going to selenium.dev and see what happening on before request sent, the things that browser is sending to us. So what are the requests that is sent? Okay, so now you can see the get request for what's happening in the network tab, and what is the request that's been sent when we hit the URL. Now we are also going to capture the responses and see what's happening. For the responses, I have added a double check, because if there is a connection drop down and if there's a cancellation from the user, if there is nothing captured in the console, I don't want to print anything. So I just want to capture network events only if there is a proper request and a proper response. So I'm just copying this and placing after the before request sent. So this is on response completed is one subscription that you have to do. You can do with network, so you can actually see the response details, what actually the browser is sending via WebSocket. Okay, and I would like to also copy the fetch thing. If there are any errors in the network and you want to see for the debugging, then you can do it. So these are the 3 subscription events that you can subscribe with the network. So I'm going to execute the command again. Going to the Selenium dev and I had few things. Now you can see the detailed login here. Okay, so this is the info that I have, which is decoded clearly from the response. So these are all the response things, the headers, and the encoding, whatever you need, you have in the response, and you can use it for the debugging purpose. Okay, so this is how you can actually see requests and responses, and you can actually intercept the network request. And you can try that out, or you can just drop a message in the Q&A or chat, so that I'll make the example ready for you. Okay, right. So there are not much common pitfalls in here. So again, the same thing. If you want to capture the network logs, you have to be more careful that you have to subscribe before requesting that network or hitting that network, right? So doing after does not make any sense, because it only captures the after logs, right? So it's always best way that you can subscribe to events before doing something, or before you want to debug what you want to debug, and hit the URL. Even I have placed a small sleep, because there might be few requests that might be still in pending, and it will take some time to send from the browser to we have socket URL, right? So I'm just waiting for until all the requests and responses are settled in here for Selenium.dev. It might be a different case for you, but you can try that out. Okay, again, you can also unsubscribe to the network events, but if you do the dev.quit, then it does all the unsubscription for you. So you should be good in this way. Okay, so I'm not sure if you have any questions. I'll just check the chat. It's the same. Okay, got it. Yeah, Maxim, do you have anything that you want to add up on any example before I jump into the next example?
No, I believe you covered it quite well. Thank you.
Great, thank you. So now we'll go with the reactive form validation, which is an interesting thing, because it actually logs the live logs when you're interacting with the form. So for that example, I have a HTML ready for you in here. So I'll open that HTML for you. Now, in this HTML, I have 3 fields: email, password, and confirm, and I have submit button in here. Now, when you do things, it just validates, but when you open the console in here, you can see a live log while you're operating with the form. Okay, so let me clear the logs for you if possible. So when I set email to test, it says in the log clearly the validation, there's a validation error for email because the format is not like a valid format, and the validation error for password, and the validation error for confirm because we have not entered any details to enable the submit button in here. Okay, so there are a lot of validations in here happening in the live. When I interact with the form, you can see now as I entered the correct email ID, or valid email ID, I can say. Now it says the validation is okay for the email, but the password is still required, and the confirm button is still required because confirm password is still required. Now I'll give a dummy password, which I have a common habit with small things. So I have entered 12345. Now you can see a different error in here. It does not say password is required, but it says min length must be 8 characters. Okay, I'll do something like TestMu 2025. Okay, now you can see there is another auto validation done in the backend. Now it says email is okay, password is okay, but confirm password is still required, right? So I have a confirm password that is a static one. I don't want to go with a dummy one. Oh, maybe I can do TestMu 2025. Now there is another log in here. If you see, when I entered password and confirm password, both are correct. Now the validation is says validation is okay. Validation for the email is okay, and validation for the password is okay. And the confirm button is the confirm password is also okay. And now it says the form is ready to submit. So this is the live interaction that I'm having, that it is doing. Okay, so you can see now when I click on submit, it says form submitted, and you'll get see a pop. So this is a reactive validation, that if you have a form that actually prints something or changes emits things in the console, or if it is a network event you want to subscribe and listen to, you can do it. So for the demo purpose, I've just created this form. Now what we're going to do is we are going to launch this page, and we are going to do some operations that we are going to perform enter dummy email, or invalid email, and capture these events in the live. Okay, and enter a wrong password and capture the event, and enter the correct password and capture the events. And when I click on submit, it also should capture the event. So the main point of using BiDi with BiDi is, it when we subscribe to an event, it will be continuously listening to those events triggered, right? So when the event is triggered, automatically it will sending that events to you, right? So this is how the BiDi works when you're doing, when you want to test in live for the reactive forms. So for that purpose, now what I need to do is I'm using the same console log, the log level. So because we are only printing the console validations in here, so I'm going to use the same on console log entry, and I'm going to capture all the console logs. But I'm going to do some extra things in here. So if you see, we have an atomic integer. So with atomic integer, what I'm trying to do is I'm trying to capture how many events are triggered in the backend. This is for to showcase you within one script validation how many events are triggered, and how many events are sent from the browser, and how many events are captured with BiDi. Okay, so now we can see the form validations are also more simple. I have the code ready that actually captures the validation logs with the validation underscore, and it should be more same that you can go with the empty file, copy the code on console entry, which is more simple. I think we have not enabled BiDi in here. I have to do that again. If you see, I'm actually subscribing before launching that page and operating on it, or performing actions on it. And if you see, log inspector is already object is already instantiated in here. Now what I need to do is options dot enable BiDi. Now this enables my BiDi session, and now everything is in place. We can register the log inspector, and now logs. What we'll do is it will be looking into the console entry, and it will capturing all the logs. So if there are any validation logs, log starts with validation and form, I'm just incrementing one with atomic integer, so that I would just want to print in the last how many events are captured. Okay, so just a check, if the submit is not enabled, you have to throw an error. That's not mandatory, but if you want to add a check, then you can add. So you can just replace all the to-dos with the code samples that are provided in the MD file for the shortcuts. Okay, now this is the script. What I'm trying to do is this is the HTML page that I'm loading with BiDi, and once it loads, I'm trying to give some bad invalid email ID. It should do something. I'm just clearing that field and entering the valid email ID again, and entering the password 123 because the min length is 8 characters now. So I'm passing again a correct password in here, and to confirm password in here, I'm clicking on the form. So if you see, it looks like a simple script, but we are actually capturing how many events that are triggered from the browser and with the BiDi. Okay. Now you can go the same. You can go ahead and copy that command to run the test, and run it. Because I'm a lazy automation engineer, I want to do a lot of capturing things. So here in the console, which is actually a live one that has captured, I'll run it again because I don't want to now see the automation page, but I want to see the console that's been triggered in here. Now you can see the console that has been captured in live, and it's providing to you, right? And the total number of events captured is 206. It depends on what you're doing, and in this execution time span, which is 10 to 15 seconds, what are the console events that is printed, we have captured, subscribed it, and we have captured it here. So the total console events are 206. So this is how, if you have a reactive form that actually changes based on your changes behavior on your browsing, then you can actually subscribe and listen to the events, network logs, or you can do whatever you want with the BiDi. Okay, this is the great feature. This is the power of BiDi. I can say that we have that limitation in the classic. Okay, now any questions so far? Anyone? Great. Okay, so the last example that I want to go with is the geolocation emulation. Okay, so what we are trying to do is a lot many people has already has went through this scenario, like they want to emulate the emulate location and start browser test, start browser automation test from that location, right? So we can also do that with BiDi, but before trying that with BiDi, what I want to showcase is this is the classic example, where in classic, when you want to emulate any location, what happens is it asks for the permission, or you have to set the profile settings in here. So to bypass this, what we have is we have a permission API. So for the geolocation emulation, we are going to use two APIs in here, to be precise. One is the permission API. Permission API is not a BiDi module, but it's an external API that can be used along with the BiDi. So it's a browser W3C module, I can say. So what we can do is, with the permission API, is we can actually fetch the origin, specific origin of the site details, not the URL, the origin details of the where the URL is opened, and we can actually set the permission types. So there are three permission types in here. I can one is granted, one is deny, and one is prompt. Okay, so when you say prompt, it's going to show the prompt and ask you have to manually enable it. When you deny it, you are directly denying the location, and when you are granting it, you are directly granting the permission, and it will actually ready to emulate that location. Okay, so this is the classic example, but if you go with the BiDi example in here, so it's more simple. Again, I'm enabling the WebSocket connection in here, and going the browsing context because I need to load the URL. So in here, I'm loading the browser leaks.geo. So I'll open in this URL. So this is the pop-up I'm saying about previously. So for now, I'll try to click on allow this time, but clicking on this might set the my profile to be always granted, so that what I can do is when we are setting the permission, I'll also try with deny in here. So I have allowed it, so have granted it. Okay. So currently I'm in Lambda test for the TestMu. I'm in Delhi. So now I'm going to emulate the geolocation, saying that I'm in San Francisco. And to do that, I'm doing the same for the browsing context. I'm navigating to that URL, and here, as I said before, I'm actually capturing the origin details, because this is required to set the permission to emulate the location. Okay, so again, the permission states are three. I have granted, deny, and prompt. First, we'll go with the granted. So once the permission is set in here, permission.set permission. So don't worry, we have this permission API and the package is available in the Selenium already. So I along with the geolocation coordinate simulation, set geolocation override. So if you want to use this, you have to be on the latest Selenium version 4.35.0. Okay, so now once you set the permission for that origin, now you are going to set the coords. Okay, so once you set the coords, automatically the location will be set to that coords, provided coords. In my case, it's San Francisco. Okay, now you can copy the command, but it points to the old one. Now what I'll do is geolocation permission. Yes, so now the permission is set to granted by default, even I have allowed it. So now you can see it says Planet Testnoida, but if you see the location now, it changed to San Francisco. Okay, so this is how I'm actually emulating the location. Okay, so here it says origin permissions is granted because I'm setting the permission to granted. Right now, what we'll do is we'll stop the script and we'll set the permission to denied and see how it behaves. I'm going to geolocation permission. I'm setting to denied and Mavently by. So now you can see the origin permissions directly move to denied. That means it is denied now. I'm not able to emulate the location. I should not be. Let me check if there is any issue with the browser leaks or still emulating. Yeah. If I enlarge the page, now you can see it says permission denied, user denied the geolocation. I didn't do anything, but it is setting the location denied after some time, because if you see the script clearly, first I'm hitting the URL, setting fetching the origin location, setting the permission to denied, and hitting that. So it is taking some time to reflect that change. Okay, so now it is denied. There are three types of permissions. Okay, so in order to use this permission API and the geolocation thing with the BiDi, you can use BiDi.emulation. This is available in the Selenium latest versions only. And the permissions, if you want to set the permission, you can use the BiDi.module.permission to set the permission. Okay, so these are the examples that I want to actually showcase in the workshop. Every example has again an MD file that you can try out. You can directly copy paste the to-dos and replace the code and execute it. And let me know your thoughts, or if you want any more examples that I want to include. And also, for the persons who are for the audience who are new to the BiDi, I have also a few BiDi terms documented in here. So you might not be these are new BiDi terms. I can say these are not the classic terms. So you need to understand what is a module, command, event, subscription, and what are the modules we have and everything. So we have a browsing context module that is mostly operated in these examples, and what is the context and what is the script module and everything. So you can go through these terms if, when you get a chance. But if you want to see the what actually the BiDi specification is, you can go through the WebDriver BiDi specification in the WC and see what are the modules available and what are the events available and what are the commands available and everything. Okay, so this is the BiDi specification in the WC where you can see every event, command, and types, what it returns, the response, and everything. Okay, so this is how the response will be when you are interacting with the BiDi sessions. Okay, so with this, I'm stopping my workshop things. But let me know if you have any questions. Just ping me in the Slack, or you can give the questions in the chat anywhere. I'll make the things ready for you. If you are able if you are not able to execute code samples, just you can raise issues in the GitHub, or you can just raise an issue in the GitHub, try to fix it or try it out. Okay, so now got it. We have a couple of minutes. We want to go few Q&As if possible.
Yeah, so thank you so much for the informative and practical session. Really, the insights into reactive browser testing with WebDriver BiDi were really enlightening, and I'm sure like everyone in this session is eager to start implementing these concepts. Since we have some time, so we can take a few questions. I can see a lot of interesting questions already coming in, and I see Maxime, addressing a few of those, but still for the people who have joined late, we can maybe take a couple of those. However, before that, I would want to just remind all the attendees that all these sessions are being recorded and will be shared with you over the email, and will also be available on the Lambda Test YouTube channel later. So, all right. So here's the first one.
So I would like to answer this, Maxim. So Cypress, I'm not sure, because Cypress started integrating BiDi 2, and Playwright is also implementing BiDi 2. But I'm not sure about the deep implementation and the backward compatibility for that. But coming to the Selenium, what we are trying to do is we were actually trying to switch between Classic and BiDi based on the user test. So there will be an auto switch happens with the Selenium 5.2. Okay. Because we're still figuring out how to make backward compatible when the user uses both, or when the user only uses Classic and when the user uses BiDi. So for now, yes, you can actually try it out and use the BiDi things in your Classic, but you have to just enable the WebSocket URL to true.
Great. Thank you. We can take the next one.
So let me answer the question. Using CDP, it's powerful. So CDP is very powerful, but it doesn't provide you cross-browser cross-browser support. Meaning you can test all the Chromium-based browsers, but not Safari and not Mozilla, which makes it which requires you to add additional set of tests which covers other browsers. So with WebDriver BiDi, you can write one test and cover all the browsers. So that's the main powerful feature of it.
Okay. This is an interesting one. Let me just pull it. Anyone, Sri? See.
So I would say, even regardless of the AI or not, this allows you to fail faster on the test. So if you aware of the console log errors, as soon as it happens, you can already fail the test and don't wait for additional side effects which will show you that something went wrong. So as the same goes for the network exceptions, for example. So yeah. Yeah, that's about the test flows, I believe. So another thing is, you don't have to poll for the page to be loaded, for example, or to some event to happen, because you can write a script which adds DOM listener and which sends a specific event. So on the preload script, there is a method that you can send message back to the script. Not sure if it's adopted or not in Selenium, but yeah, in the protocol there is such a mechanism.
Yeah, thanks for answering that. Let me look one more.
So
I believe
it's the same answer I can say, because is the WebDriver BiDi runs on the WebSocket connection. You can subscribe to the live events and listen to the live events, right? That we cannot do with the Selenium Classic. Selenium Classic, how it works is it only sends the request to the browser, and we have to poll until something happens with the browser, and until the browser responds, right? Uh, until then the Selenium has to wait to send another request. But with the BiDi, it's a bidirectional communication. You can actually see what's happening at the browser side, and as it event find, and it finds the event and it gives the response to you immediately, right?
Yeah, I think we have covered most of the questions during the session. However, we will wrap up with this last question.
Okay. This is interesting. Maybe Maxim, do you want to take it?
So from the protocol perspective, I assume that JSON wire means WebDriver Classic. So if my assumption is right, then, well, we don't invest anymore to adding new features to WebDriver Classic, even though we most oftenly we push back and ask external contributors to add WebDriver BiDi instead of WebDriver Classic new capabilities. So from that perspective, we don't expect WebDriver Classic to grow at all. And one of the goals of WebDriver BiDi is to be able to implement everything which is currently possible via WebDriver Classic. So will it be completely replaced or not? It's a question to the testing frameworks which already use WebDriver Classic. However, we are from the CDP perspective, in PPT, for example, we are aiming to provide the same functionality for WebDriver BiDi protocol as we provide for CDP browsers.
In addition to that, if you see the browsers now, not all browsers have implemented the WebDriver BiDi. They are not WebDriver BiDi ready yet, right? So there still runs on the WebDriver Classic protocol. So the browser automation tools still has to go with the classic WebDriver API in order to support the older browsers that has not BiDi ready. So this is not going to happen soon. But the main idea is to combine the power of WebDriver Classic and the CDP is what the WebDriver BiDi is, right? So we are making a lot of features, combination of features with CDP and Classic to BiDi, but we are not deprecating the WebDriver Classic yet from the tools perspective.
I added the link to the chat for the current. Oh, sorry. I added the link to the chat to the current implementation state of the different browsers. So we use WPT, which is Web Platform Tests, to measure the implementation. So it's set of tests, and each browser shows how much of them they pass. So yeah, you can check the implementation status
you can
there.
share the screen and show for the users who are not.
Oh, sure.
Shazib, can you close that so that we can share?
Yeah.
So this is current implementation status of different browsers. So as you see, even WebKit has some implementation. So some work is going on there.
Got it. So Chrome and Firefox are BiDi ready. and still work is going under progress, but Safari, yeah, it needs to start.
Yeah, so thank you so much, Maxime and Sri, for answering the questions. And to our amazing audience, thank you for joining this session. If you have more questions, you can put them on the Lambdas community, the link to which is given in the chat. And if you haven't already, do share about your favorite moment or the learnings from this session on social media with the hashtag TestMuCon, so that we can select the winners and give away the prizes. So thank you once again for joining us. Have a fantastic day.
Thank you, everyone.
Thanks, everyone.
Yeah.